Good morning, students. Today we will discuss an important section in calculus, that is Laplace transform. Laplace transform is an integral transform. First, we understand what is the definition of the Laplace transform. Definition. Let f of t be a function. F of t be a function, t greater than or equal to 0. F of t be a function where t greater than or equal to 0. Then Laplace transform of f of t, which is denoted by L of f of t. Laplace transform f of t, which is represented by L of f of t, is defined as integral e raised to minus st into f of t dt within the limit 0 to infinity. But to obtain Laplace transform of function f of t, we multiply that function by e raised to minus st. We multiply f of t by e raised to minus st, whereas greater than 0. After multiplying, we integrate this with respect to t. And after the integration, evaluate the lower limit 0 and upper limit infinity. Then we get Laplace transform of a function. L of f of t. For example, when we take f of t is equal to 1, then we can find the Laplace transform of 1. Laplace transform of 1 is equal to, we multiply the function 1 by e raised to minus st. That is 0 to infinity e raised to minus st into 1 dt. To obtain the Laplace transform of the function 1, we multiply the function 1 by e raised to minus st. Then integrate with respect to t. And evaluate within the limit, lower limit 0, upper limit infinity. When we integrate e raised to minus st with respect to t, we get e raised to minus st by minus s, then 0 to infinity. We can take 1 by minus s outside. Then our result will be e raised to minus infinity minus e raised to 0. When we are applying the upper limit t, infinity, we get e raised to minus infinity. Lower limit 0, we get e raised to 0. Then we get 1 by minus s into e raised to minus infinity. The value of e raised to minus infinity is 0. E raised to 0, 1. Therefore, our answer will be 1 by s. Therefore, Laplace transform of the function 1 is equal to 1 by s. This is the procedure to obtain the Laplace transform of function. Above, here the function f of t is equal to 1. To obtain the Laplace transform, we multiply that function by e raised to minus st and integrate with respect to t and evaluate within the limit 0 to infinity. We get the answer is 1 by s. Here e raised to minus infinity is equal to e raised to minus infinity is equal to 0. Therefore, 0 minus 1. We are releasing the brackets. The answer will be 1 by s. Similarly, we can find another function, Laplace transform. We can find the another function, that is f of t is equal to e raised to at. Here we have to find out the Laplace transform of e raised to at. For that, Laplace transform of e raised to at is equal to integral 0 to infinity e raised to minus st e raised to at dt. We multiply the given function by e raised to minus st. This can be arranged as integral 0 to infinity e raised to minus st plus at dt. That is integral 0 to infinity. We can take minus s, minus t outside. Therefore, s minus a dt. We take minus t outside. Therefore, s minus a into dt. Integrate e raised to minus t into s minus a. We get the answer is e raised to minus of s minus a into t divided by minus of s minus a. then 0 to infinity. 1 by minus of s minus a taken outside. Then we applying the upper limit. When we applying the upper limit, it will be 0. Then lower limit we get 1. Then releasing the bracket, we get 1 by s minus a. Therefore, Laplace transform of e raised to at is equal to 1 by s minus s. 1 by s minus e. But we should remember some standard results in Laplace transform. These are the standard results. I will write the standard results. The first one, Laplace transform of 1, that is equal to 1 by s. To obtain the Laplace transform of 1, we multiplying the 1 by e raised to minus st, then integrate with respect to t, and applying the limit, lower limit 0 and upper limit infinity, we will get the answer as 1 by s. Similarly, the second result, Laplace transform of e raised to at, that is equal to 1 by s minus a. Laplace transform e raised to at, Laplace transform is equal to 1 by s minus a. Then third result, Laplace transform of e raised to minus at, that is equal to 1 by s plus a. 1 by s plus a. Then fourth result, Laplace transform of sin at. To find the Laplace transform of sin at is multiplied by e raised to minus st, then integrate within the limit 0 to infinity. The answer will be a by s square plus s square. Then fifth result, Laplace transform of cos at, s by s square plus s square. Sixth result, Laplace transform of sin hat, hyperbolic function. Sin hat is equal to a by s square minus s square. Then seventh result, Laplace transform of cos hat is equal to s by s square minus s square. Eighth result, Laplace transform of t raised to n, that is n factorial by s raised to n plus 1 or gamma n plus 1 by s raised to n plus 1. These are some standard result in the Laplace transform. You should know all the standard results. Based on this standard result, we can easily solve the ordinary differential equation and we can find the value of y. By using Laplace transform technique, we can easily solve the ordinary differential equation. For that, you should remember these standard results. The standard results are the first standard result, Laplace transform of 1, that is equal to 1 by s. Laplace transform of e raised to at, 1 by s minus a. Laplace transform of e raised to minus at, 1 by s plus a. Laplace transform of sin at, a by s square plus s square. Laplace transform of cos at, s by s square plus s square. Laplace transform of sin at, a by s square minus s square. Laplace transform of cos at, s by s square minus s square. Laplace transform of t raised to n have two formula. One, n factorial by s raised to n plus 1 and gamma n plus 1 by s raised to n plus 1. These are the important formulas in the Laplace transform. Next class, we can do some problem in the Laplace transform. Okay.